Hey guys, so today's video is the test review. So I'm going to be doing the odds and then you all will be doing the evens on this test review. So the test tomorrow is over radicals and rational exponents. On this first section, we are simplifying each of these radicals. So remember, when we simplify, it's based on the index. So on number 1, we have an index of 4. We are going to take 32 and change it to its prime factors, which is 2 to the 5th, of x to the 4th, y to the 8th, and z to the 8th. So each of the exponents are greater than 4, so each of them will have something that comes out. We're going to divide the exponents by our index. We get 1 with a remainder of 1, 1 with no remainder, 2 with no remainder, and 2 with no remainder. So I'm just taking each of those exponents, dividing by 4. And now that first number becomes what's on the outside, the power on whatever we had. So 2 has a power of 1, x has a power of 1, y has a power of 2, and z has a power of 2. And then left on the inside will be whatever had a second number, and the only one with the second number was 2 with a power of 1 on it. So when we write our final answer, I do like to remove the dots, and then if there are powers of 1, I'll just write them without the power on there. So we have 2x y squared z squared 4th root of 2. And then that will be our final answer. Then on number 3, now we have an index of 3, so we're going to be taking out anything that has a power of 3 or more, and of course we're going to find the prime factors for 256, which the calculator tells me is 2 to the 8th power, and we have an m, a p squared, and a q to the 5th power. So we're only going to be circling the pieces that have a power that's greater than 3, so 3 or more. So we've got 2 to the 8th, 8 divided by 3 is 2 with a remainder of 2. M does not have a power of 3 or greater. P does not have a power of 3 or greater. Q does. 5 divided by 3 is 1 with a remainder of 2. So on the outside we've got 2 with a power of 2, no M, no P, and a Q with a power of 1. On the inside we have a remainder with the 2's. The M stayed inside, the P stayed inside, and then we had a remainder with the Q's as well. So again, when we write our final answer, I like to write it, we're going to change that 2 squared to a 4 so we don't have a power on it. Q, cube root of 4m p squared q squared. And then on number 5, we've got 108v, and we're taking the square root. So remember, when we don't see the index, it is 2. So as always, we'll take the prime factors of 108. We've got 2 squared times 3 cubed, and then we've got that v in there. So since our index is 2, anything with a power of 2 or greater, so 2 divided by 2 is just 1. 3 divided by 2 is 1 with a remainder of 1, and v doesn't have a power great enough. So on the outside we've got 2 with a power of 1, 3 with a power of 1. Then on the inside we don't have any 2's remaining, we have 3 remaining and the v in there. So 2 times 3 is 6 on the outside, and then on the inside we've got 3v. Now on the next part, we're writing each expression in radical form. So we're converting rational exponents to radical form. So x to the power of 5 over 2, we're going to have our radical symbol, x on the inside. And so this bottom part is whatever my index is, and the top part is my power. You may see it like that, or you might see it like that, or you may see it like that. So since the index is 2, we won't see the index in there. We're just going to have the radical symbol, and then sometimes the power will be on the outside of parentheses, and sometimes it'll be underneath the radical. It means the same thing. So remember, with our rational exponents, it's power over index. So on number 9, again, this is power over index, and so underneath the radical, 6n is going to be in there. And since we've got 2 terms, I am going to write it in parentheses. 5 is the power, 3 is the index. If we wrote it like this, then it looks like only the n is to the 5th power. So another way to write it, where we're giving that power to both 6 and n, would be to put the parentheses underneath the radical. Then on the next part of the review, we're writing it in exponential form. So remember, our exponents are power over index. So this would be 3n to the power of the power over the index. So this is 3n to the 5/3 power. And we do have to make sure that there's parentheses so that both 3 and n are getting that power there. Then on 13, whenever we have no index written there, it is a 2. And whenever we don't have a power written there, it is a power of 1. So we've got 6k to the power of 1/2. Another way to remember that is that any square root is always going to be to the power of 1/2. So a plain square root, since we had a plain square root of 6k, we're taking 6k to the power of 1/2. Now in this next part, when we're simplifying, we're going to be using our exponent rules. So we're taking a power to a power on number 15. So a power raised to another power, we're going to multiply them. So we have n to the power of 8 times 1/2, which is n to the power of 4. Same thing on number 17. We're taking 8n to the 6 to the power of 5/3. So we're taking both of those to the power of 5/3. So we're going to take 8 to the power of 5/3, which is 32. And n to the power of 6 times 5/3, which is the power of 10. So we've got 32 n to the 10th power. Now on this bottom, we do have some multiplication, some addition, and subtraction. So on 19, we've got subtraction and addition. Remember that when we subtract and add, the first thing we want to do is simplify so we can check what we can combine. So this first one, we're going to find the prime factors of negative 24, which would be negative 1 times 2 to the 3rd times 3. Then 81 is 3 to the 4th power. And 135 is 3 to the 3rd times 5. So now we've got them all written out with their prime factors, and we'll simplify based on those. -1 with an odd is always going to come out. 2 to the 3rd, that'll come out with no remainders. 3 to the 4th will come out once with a remainder of 1. 3 to the 3rd will come out without a remainder, and then 5 does not have a power on it great enough. So on this first one, we've got -3 times -1 times 2, cube root of 3, plus 2 times 3, cube root of 3, plus 2 times 3, cube root of 5. So that's 6 cube root of 3 plus 6 cube root of 3 plus 6 cube root of 5. And we can only add or subtract when the entire radical looks exactly the same. So the index is the same, the radicand is the same, and everything underneath, everything on the outside. So here is the same, here is the same, and this is not the same because 5 is underneath. So 6 plus 6 gives me 12 cube root of 3, and then we keep that 6 cube root of 5 the way that it is. It won't combine with anything. Now on number 21, 6 and 5 are prime numbers. Sorry, 6 is not a prime number, but it won't have anything that can come out is what I meant, because 6 is 2 and 3, but 5 is a prime number. And then 45 is 3 squared times 5. So 2 and 3, neither of them have a power of 2 or greater, so they're going to stay the same. 5 doesn't have a power of 2 or greater. And then here, this has a power of 2, so the whole thing will come out with no remainders. So we have -3 square root of 6 minus 2 square root of 5 plus 6. We're going to have that 3 come out multiplied by the 2, square root of 5. And then we'll combine based on whatever's the same. So this square root of 5 is the same, but this square root of 6 is not. So we've got -3 square root of 6 plus 4 square root of 5. So we got that 4 as the coefficient from 6 minus 2, or -2 plus 6. Now on 23, we're dealing with multiplication. So when we're multiplying, we're going to take that first term and distribute just the same way as we would with any other number, any other variable. So with our radicals, we'll multiply whatever's underneath by whatever's underneath. So 10 and 5, we get 50. R and R, we get R squared. And then 2R is on the outside, so it'll remain on the outside. And then 10R will remain on the inside. So now we will simplify what's underneath the radical. So 50 is 5 squared times 50. If we do our factor tree, we got 5 times 10. Which is 5 times 2. So it's 5 squared times 2, or 2 times 5 squared. And then 10 is just 5 and 2. And then we'll simplify based on their powers. 5 squared and r squared will come out to the front with no remainders. So we've got 5r square root of 2. And then here on this 2r square root of 5 2r, we don't have any powers that are 2 or greater, so it's going to remain the same, 2r square root of 10r. And since they don't look the same underneath their radicals, we cannot combine them any further. Now number 25, we've got foiling that has to happen, some distribution. So if it's hard to tell where each of your terms stop, then box them in, draw circles around them, whatever you need to do so you can see where each of those terms stops and starts. So we're going to take this square root of 2 and multiply by both of these terms. So square root of 2 times negative 5 square root of 2n. Since square root of 2 is underneath the radical, that's where that multiplication is going to occur. So we'll have 4n. And then we've got square root of 2 times negative 2 square root of 5. So again, the multiplication is only occurring underneath since that is where the square root of 2 is. So we've got 2 and 5, which gives me 10. And then on the second part, we've got coefficients on the outside, so we'll multiply them together, 5 and negative 25. And then underneath the radical, we'll multiply, so 5 and 2 gives me 10. And then that n stays. And then again, coefficients with coefficients gives me negative 10. And underneath with underneath gives me square root of 25. So now we're at the step where we can start simplifying. So negative 5 square root of 2 squared times n minus 2 square root of 2 times 5 minus 25 square root of 2 times 5 times n minus 10 square root of 5 squared. 2 squared will come out with no remainders. N doesn't have a power of 2 or greater. 2 doesn't have a power of 2 or greater. 5 doesn't have a power of 2 or greater. 2 doesn't have a power of 2 or greater. 5 doesn't have a power of 2 or greater. N doesn't have a power of 2 or greater. And then here, this is a power of 2, so there's no remainders. So we've got negative 5 times 2 square root of n minus 2 square root of 10 minus 25 square root of 10n minus 10 times 5. So we're still not done simplifying. None of my radicals are the same, so we'll just keep them. We've got negative 10 square root of n, negative 2 square root of 10, negative 25 square root of 10n, and minus 50. And then none of them match, so we would have to stop there, and that would be our final answer. So that is it for what I will be solving on this video, and then the evens are for you to do and then turn in on Canvas. Be sure to study up before your test tomorrow, and each of these topics will be covered on the test.